Okay, so in our continued pursuit to understand the concept of density, we went ahead and looked at sinking and floating. However, sinking and floating usually is with liquids and solids, and what I want to show you is the same concept applies to gases. What I'm going to show you is I'm going to make a gas through a chemical reaction, and this gas is going to be more dense than air. Now, gases at the same temperature and pressure are roughly take up the same space. So what I'm making is a gas that's actually heavier per unit volume, and therefore it's more dense. So let me show you what that looks like. I've got some baking soda here. I'm going to go ahead and pour in some vinegar. You guys have all seen this reaction before. And what I'm trying to do is make a bunch of gas. A little overflowing, but that's okay. Let's just let those bubbles seep down. This is something you guys have probably done many times. But now I've made some CO2, and I want you to watch this because this is almost magical. Here we go. There's my jar full of gas, and watch what I'm going to do. Did you see that? Was that not cool? Let's see if we've got enough gas to do that again. I've got a candle here, right? And candles need oxygen to burn. I've got some CO2 in this glass. I'm going to pour out this CO2 even though you can't see it. Look at that. If that isn't the coolest thing. So what's going on is you've got this gas that's pouring out just like water pouring out of a beaker. It's the same concept. Gases are fluid, so they're going ahead and pouring out, and it's pouring out right over to the top of the flame, putting it out. Pretty awesome. I never get tired of looking at that. So again, the idea is that density still plays a role whether you're a solid, liquid, or gas. If the density is greater, it will sink in whatever fluid it's in. If it's less dense, it will float. There you have it.